Now, I want us to consider this particular implementation of method to solve problem. So we are making use of the algorithm to solve this particular problem. And the problem we want to consider here is 2 by 2 matrix. So considering this part here, this particular problem here, we are given a two system of linear equation. Looking at this is a linear equation. We are given a linear equation of y1. Hold on. So we are actually given a system of equation of y1 equals y1 equals minus 5x1 plus 2x2, and y2 is also given as what? Minus 9x1 plus 6x2. I can decide to write this thing. I can find the augmented matrix for this. And augmented matrix for this is that I will turn this to vector form such that y1 and y2 represent just y equals. I will try to generate a matrix for this, a matrix A. Matrix A implies the coefficient of these variables minus 5 2 minus 9 6, right? Multiplied by what? By x1 x2 x1 x2. This x1 x2, I'll call it what? I'll call it a vector v, or you use capital X. So y is always equals to ax. But to get this clearly, to write this clear, that means what this is what I meant. So as if we have y1 y2 equals matrix A. What's matrix A? You know, why is this? Why represent this? What's matrix A? Matrix A represents minus 5 minus 9 2 6, right? And the vector matrix implies your x1 and x2. It's still the same thing with this. So if I multiply this and this together, I will have this result. Minus 5 times x1 is minus 5x1 plus 2 times x2 is minus plus 2x2. If you do the same thing for this one and this one, you have this one back. So you see, it does not really affect. So that's what this is trying to tell us. This is y equals to AV. Y represent this. My matrix A represent this. My vector is x1, x2. So then how can you actually get, how will you get your eigenvalues? By formula, matrix A minus lambda I, the determinant is always equals to 0. This characterizes equation, which says that my matrix A, I've gotten my matrix A as what? As minus 5 2 minus 9 6. Okay, minus lambda of what's my identity matrix? That's 2 by 2. Since my matrix A is 2 by 2, I'll use 2 by 2. Find the determinant and equate it to 0. So you know how to solve this now. Minus 5 2 minus 9 6 minus lambda times 1 is lambda. Lambda times 0 is 0 0 lambda. So you need to subtract this matrix and find the determinant. Subtract this, you have minus 5 minus lambda. This minus this. 2 minus 0 is 2. Okay, this minus this is minus 9, and 6 minus this is 6 minus lambda. Find the determinant of this guy here, and then put plus or minus, first multiply. If this multiply this, you know what you get. See it here, minus 5 minus lambda, multiply. Okay, I think it's on the next page. Okay, minus 5 minus lambda, multiply this. See it here. And this minus 2 multiply this, you have this result. So when you now have this equated to 0, this formula here is equals to 0. So you have a quadratic equation here to be equals to 0. So lambda plus 3, lambda minus 4 is equals to 0. So lambda is equals to minus 3 or 4. Now you have two results. So my eigenvalues are minus 3 or 4. How do we find the corresponding eigenvectors? You will need to come straight back to this and substitute. To find the eigenvector, remember that the rule given to us is, the algorithm step given to us is just a minus lambda I is equals to 0. And you know what to do from here. What's my A? My A is minus 5 2 minus 9 6 minus, what's my lambda? 3. That's plus 3 of 1 0 0 1. But there's no way you can actually find your vector from your eigenvectors from here. But to find the eigenvector, see what to do here. Go back to this expression. Go back to this equation. Do you know where I actually got this from? It's actually from that minus 5 minus lambda. Okay? Minus 5 minus lambda, but multiplying x1 plus 2x2. Remember now, this is where it is. Look at this. This is where we got it from. Okay? See it here. From this. Just substitute the value for lambda, leave x1 and x2. So x1 and x2 will give you the eigenvector. So when you try to express, you have minus 2, this will give you 2, and you have this result. So divide 2 by 2 in this case, minus 2 rather. You have this. So how will you solve this equation? You have x1 minus x2 is equals to 0 and x1 minus x2 is equals to 0. You can set your x1 to be equals to anything. Anything you are free. If I use 2, that means minus x2 is equals to minus 2. Minus cancel minus x2 is 2. So if x2 is 2, you have x1 minus 2 is equals to 0 in this second equation, and x1 2 will be equals to what? 2. So x1 is equals to 2 and x2 is equals to what? 2. So the eigenvectors is just x1 and x2. This is the eigenvector. Remember, from this definition, which says our y is equals to AV. This is the eigenvectors. This is the eigenvector. And the eigenvector from there was x1, x2. What was our v? Our definition for v is see it here. Our definition for v, these are eigenvector x1 and x2. So our x1 and x2 is just 1, 1. We got it as 2, 2. That's what we got. 2, 2. So no matter what you use, there are variety of answers. You can actually get different answers for eigenvectors. Just like I've stated it here. I said it here, which says choose a convenient value for x1 and x2, anyone you want. They are infinite solution, of course. Bx1 is equals to x2, so you can get any variety of solution. So this is 2 and 2. But is this result this 1 1? Yeah, I use 1 1. Okay, yeah, I use 2 2. So we got 1 1. Is it correct? How will you know that it is correct? You can actually test now from this expression, which says our a times vector 1. Okay, from our y equals to a vector 1. So let's confirm. What's our matrix A? See it here. What's our vector? See it here. Multiply this and this together, you have minus 3, minus 3. So when you now look at this now, what we have? If you look at this thing clearly now, it simply implies that I can factor out minus 3 and I have 1, 1 inside. I will get the eigenvectors back and I will get minus 3. This minus 3 is corresponding to what? It corresponds to that of what? Um, the lambda we got. Had it been you substituted it and you now have minus 2 in this case, that means it is not correct. So that is how it works. So I think this is not the end of the solution. We still need to find when lambda 2 is what is 4. So if Dr. Osa has to do it, no problem. I will help you out on that. Is that clear? So for lambda 2 is equals to 4, you know what to do in that case. Just follow the same steps. The same step. Minus 5 minus lambda of x1 plus 2x2. Minus 5 minus lambda of x1 plus 2x2 equals to what? 0. Now which one again? Minus 9x1 plus 6 minus lambda minus 9x1 plus 6 minus lambda of x2 is equals to 0. So lambda is 4. That's minus 5 minus 4. That's minus 9x1 plus 2x2. This one is minus 9x1 plus 6 minus 4 is what? Is 2x2 equals to 0 equals to 0. So I think if you subtract both sides, what happens? This will go off and you have 2 minus 2. This also goes off. No result. So I think there is no result for 4. That's why there is no need for you to show the solution. The solution does not exist for x equals to 4. Okay, so that is all I can explain for now, Sha. But make sure you find a way to summarize all this that I've explained so far. Is that clear?